Data types. Every value in Rust is of a certain data type, which tells Rust what kind of data is being specified so it knows how to work with that data. We'll look at two data type subsets, scalar and compound. This is not where I'm supposed to be. I'm supposed to be at floating point types. Rust also has two primitive types for floating point numbers, which are numbers with decimal points. Rust's floating point types are F32 and F64, which are 32 bits and 64 bits in size, respectively. The default type is F64 because on modern CPUs it's roughly the same speed as F32, but is capable of more precision. Here's an example that shows floating point numbers in action. Function main, let x equal 2.0 semicolon. Let y equal let y colon F32 equal 3.0 semicolon. Floating point numbers are represented according to the IEEE 754 standard. The F32 type is a single precision float, and F64 has double precision. Numeric operations. Rust supports the basic mathematical operations you'd expect for all of the number types: addition, subtraction, multiplication, division, and remainder. The following code shows how you'd use each one in a let statement. So let sum equal 5 plus 10. Let difference equal 95.5 minus, that's a dash, 4.3. Let product equal 4 asterisk 30. Let, this is division, let quotient equal 56.7 slash 32.2. And remainder would be let remainder equal 43% sign 5. Each expression in these statements uses a mathematical operator and evaluates to a single value, which is then bound to a variable. Appendix B contains a list of all operators that Rust provides. The Boolean type. As in most other programming languages, a Boolean type in Rust has two possible values, true and false. Booleans are 1 byte in size. The Boolean type in Rust is specified using bool. For example, you could have let t equals true, and then let f colon bool equal false. Okay, so that is with explicit type annotation. The main way to use Boolean values is through conditionals, such as an if expression. We'll cover how if expressions work in Rust in the control flow section, and then tell you to use match expressions instead. The character type. So far, we've worked only with numbers, but Rust supports letters too. Rust's char type is the language's most primitive alphabetic type, and the following code shows one way to use it. Note that char literals are specified with single quotes, as opposed to string literals which use double quotes. So we've got Rust char type is 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just ASCII. Accented letters, Chinese, Japanese, and Korean characters, emoji, and zero-width spaces are all valid char values in Rust. Unicode scalar values range from U plus 0000 to U plus D7FF and U plus E000 to U plus 10FFFF inclusive. However, a character isn't really a concept in Unicode, so your human intuition for what a character is may not match up with what a char is in Rust. We'll discuss this topic in detail in Storing UTF-8 Encoded Text with Strings in Chapter 8. So I went and found a little crab, and we're going to put him somewhere. I don't think that was it. Oh, it is it. Oh. Oof. Well, maybe I'll edit this. So, I've got this little, yeah, I went and found a poo-poo. Yeah, that's nice. And a little crab. So we can say, we'll just do what they did. We got, oh, that's not it. We'll say, let Ferris equal, why do people say equals? Let Ferris equals, they say. I want to say let Ferris equal. And now we're going to yank this little crab, I guess. We yank just one character. Gosh, I'm bad at Vim. So, haha. Oh. So we can, oh, I know. This, and then yank. Right. So, Vim skills for the win. Wait, okay. And now P. Yes, I did it. I've gone and done it now. Oh, how about this one? That's an uppercase J. Okay, so we're letting Ferris equal that little Krabby Crab with oops, a semicolon. Okay. Now we got to do something with him. So we will print on. Yeah. Okay. This, I guess. We'll say it's Ferris. I call this Ferris. All right, and then just kidding. Space. And we'll say Ferris. What do we get? Great. Okay. Terminal like this. Wonder if hey, there we go. Cargo run. I really like NeoVim. It's Ferris. There he is. And can I? Okay, so if I quit that, oh, well, that's no good. Okay. Compound types can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. Tuples. Excuse me. A tuple is a general way of grouping together some number of other values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values inside parentheses. Each position in the tuple has a type, and the types of the different values in the tuple don't have to be the same. We've added optional type annotations in this example. Okay. Maybe put Ferris in a tuple. You want to go in a tuple? You want to go in a tuple, little buddy? Let. See, and I got real confused the first time going through this because they're all like, let tup. That is just their variable That's just the variable they used. You don't have to use tup. That got me. So what are we going to call this? We'll call it a bucket. Let bucket, and then we got this stuff. We'll say, oh my gosh. See, they're putting just like some numbers in there. I want to put a string in my tup. I want to put a slice. Put a slice of a string. What if, I wonder if I remember correctly stuff that I've come across. Let's find out. So we can say bucket equal stir, and then char. Let bucket, yeah, stir char, okay, equal, and then, do I still have him in the, okay, let's go get some Ferris. Visual yank. And then put him. There we are. Okay. And then we want a comma and a space. Oh, that's where the stir goes. So how do we do this? What if it's this? Yeah. It's Ferris. Okay, so it's Ferris. But then this has to be, this can't be formatted that well. Let's see what happens. And then we're going to come down here and our print line will just be, that's not what I meant to do. What did I even do? Not you. Oof. Okay, so yeah, we'll come in here and say change inner parentheses, and then the print line will be the dupe. Oof, I'm making this up. Trying the stuff, making it up. Let's see what happens if I just say bucket here. Alright, I don't think that the line is gonna work. Yes, I mean not the line, the string. Oh Lord. Unknown start of token. Char. Okay, wait a minute now. Did they have any issue with Ferris? I mean, it's Ferris. So that's a stir. Okay. I guess that seems okay. And then, so what if I say, can I do this? Oh, that's not where I was. I mean, it's not where I was trying to be. Come on. So if I do this, how about that? Right. Okay. Like this. There's always more. Oh, hey, yeah, mismatch types. All right. So, what if we go like this? Does that get Ferris in the scope? Oh, here we go. So this is talking about the string. So we'll say size values for type stir. So what if I say dot into blam blam? Does that fix it? No. Okay, how about the we got this little thing right here. Does that do it? Oop. Gosh. I'm so bad at Vim. Insert. That, and then the question mark. And then get out. And then right quit. Seems like less errors. Yeah. Well, there's another one. What if it's... oh gosh. Next. Doesn't work. Okay. Isn't there another one? Like to string? To stir? To string. Yeah, let's try that. To string. But is this fewer errors? Same errors? Okay, mismatched types, right. Okay, but then the size for values of type string cannot be, slice cannot be known at compilation time. I guess it's a slice. Stir. Wonder if I want to post this video of me struggling. Okay, I'll get this right eventually, but I guess not now. So we're not gonna want to stir. We're gonna want to. Okay. All right. So we can go ahead and blast this. Let's say that. How about that? Yeah. Okay. So term, and then we will. Carter run. Boom. Yeah, it's because I did the debug flag in the Okay, moving on. The variable tup binds to the entire tuple because a tuple is considered a single compound element. To get the individual values out of a tuple, we can use pattern matching to destructure a tuple value, like this. Yeah, okay. So, too bad this quit doesn't take me back to the file I was in. Oh, well, look at that. It's not too bad. So, we will print line. Change inner, is that a thing? I guess I can say, oh, how about this? I'll say, it's Ferris. And then I have, right away, I'm going to do this with no space, and then I will have a space, and then I will have the other one. Right. Okay, so now I come here and say the first one is, wait, so all I have to do is, okay, so let tup equal that, and then we will let, so this is, what is this calling? Destructuring a tuple. So we have to destructure a tuple. Let's say that, and then let yeah, okay, that makes sense. So then we'll say let this equal bucket. How do we do? Not too good. 2 positional arguments in format string, but there is 1 argument. Oh. Char doesn't implement std display. Does it work if I, oof, you know, that's Dvorak problems right there. That's what that was. That's not what it was. Okay, so do this right here. Yep. And then I come over here, do it again. Okay. So one argument, right? Why? Oh, duh. Yeah. Bucket. I forgot to change that. Okay, wait a minute now. So this... Oof. So we... Okay. We have let bucket equal char. Then they have let the destructurization of bucket equal bucket. So the bucket doesn't need to say, yeah, they actually did a little switcheroo here, didn't they? So we're gonna yank this little fella, yank him, and then put him here. That didn't work. Oh right, so I deleted the line. I mean, because I deleted the word. Oof. All right. Okay. Delete. Enter that thing. Come back up here to him, and I will visual and yank. And I come down here for the put. Then comma. Let's put Ferris second. Just because that's how we're gonna print it. What are we gonna call the... So I just need to get rid of this altogether. Pretty sure. What we got going on here? Okay, so we have let. So we're letting bucket. Wow, did I? Huh. I'm not sure I had this anywhere near right before. Yeah, unknown token. Well, should I flag it as something? Should I say this guy and then char? Wait, is that how you do it? Space? Like that? Can I put it in right before like that? Does that work? Alright. I don't think I'm gonna want to watch this. So it seems like I had this problem before. Unknown start of token. Let's look at the rest of this and see if it... Yeah, that's why I had the let Ferris in the first place, right? Yeah, okay, so let's put that back in. So we will let Ferris equal oh yeah, I could, if I leave that one down there, I don't have to worry about okay, up to the top, put right, so we're gonna let Ferris equal this little puppy. Okay, now we're letting bucket equal Ferris. And then the second thing can actually be the value. So I don't have to name it a variable. I wonder if this is even going to work, putting a variable inside there. And it seems like I just did it, so I should know if it works. Yeah, and then we'll say that. Okay. Okay, so now, instead of bucket here, we will say the first one is wait, yeah, okay, so now we're gonna call this I am figuring this out. I am getting it. You don't think I'm getting it, but I am. I'm learning here. Learning the stuff. Perhaps not talking as much as I should be. Yeah, so the reason I started doing this, if anyone is watching, I really learn better by listening than reading with my eyeballs. And a lot of times, I'm not a programmer. You might have noticed. I just wanted to learn Rust. And as I was learning, I realized I'm learning stuff and then forgetting it. So this is kind of just like a for me to come back and find in the future. Okay. I didn't give any arguments. I wonder if I can get rid of the debug business. The first one will be EXP. Ho ho. The second one will be Ferris. Eh? Oh wait, that's not the. Okay. You wanted that? Oh. Yeah, sure. Okay. Oh, that's such a nice feeling. Let's try a split instead. So we will, whoops. Did I do something? Yeah, go back. All right, so split and terminal, does that work? Ooh, it's split above. Meh. Split. Yeah, I like that better. So now we can say terminal. Cargo run. Run, cargo, run. It's Ferris. Oh. There are little char quotes. Oh, I wonder if that's from I wonder if that is from the debug flag. I shouldn't sigh, because you didn't know that's not what I was trying to do. There we are. Right, okay, so undetermined double quote string. Oh, I lost it. So it'll be here. Then we need that. Oof, this is looking good. Looking good. I'm happy. That's not what I was looking for. How about that one? Yes, and then we will cargo run. Blam. It's Ferris. It is Ferris. This has gone on quite long enough.